G'day everybody and welcome back to the channel. I've only got a very small video here. This is still the same night. I just uploaded a video about some amplifiers and a few little updates and things. And I've just done a few more things and made a few more decisions on this. So I wanted to just go over it quickly. One thing I've noticed that's stood out on here the whole time that I haven't pointed out is I had these two tracks just directly connected to here. It is not being laid out like that by any means. You know, every time you see something coming down to 0 volt, that's star grounded. Every time you see, you know, I forgot. Don't know what that line's doing there. Anyway, you get the gist. So yeah, you know, it's going to have its own separate wires that go back to the cap bank. It's not going to be seeing the voltage go up and down on this trace. Just wanted to point that out. I know some people probably already assumed that anyway, but I have to assume that some people could be learning or trying to replicate it, and you know, I don't want people to have problems and then be chasing their tail because I've done something silly like that. Right, so with this little circuit here, this is my input circuit. The signal from the RCA goes through a 560 ohm resistor, 100 mic cap. These are the capacitors I've chosen. These are those SI brand ones from J-Car. Non-polarized, 100 mic, 50 volts. So these have got low ESR, they're non-polarized, and they're a good quality cap. I mean, you're not going to get better for electrolytics, for audio purposes, than that really. I mean, I don't like electros in audio, but they're not going to do anything to the signal. They're good. And 100U, like, yeah, non-polarized, that's not going to screw up anything. Other thing I've decided to do is go with carbon film for the 15K and the 560 ohm there. Again, less inductance, right? I don't want metal film in the signal path, especially for resistors with a higher resistance, because there's going to be more smaller amount coiled up unless it's carbon composite. But I'm sure these are carbon film. Who knows? I'm pretty sure it's going to be more inductive the higher the resistance is. So, anyway, whether I'm right or wrong about that, these are certainly less inductive than metal film. So, that's my choice for that. Now, I don't know that I will be using this circuit. This circuit is the circuit that goes to here. So, these 2 points here go to here, and then these 2 points here go to the 0 volt rail that all this is star grounded to, and the other point goes to this 4.7 mic film cap to the bias network. That's how it gets the signal in here. And incidentally, yeah, the feedback network is just exactly what you would think. Just a resistor and a capacitor in parallel coming off the output and going back to the input. Literally, nothing more to it. Well, with this amplifier anyway. Now, I actually like this because it's simple and it works really well. It provides a good load. The input signal sees a steady 15K load, and you know, most equipment drives that nicely, and you have not only it's able to drive it, but that load is also good for the cable. If you've got a long cable, you know, it loads it. So I've used this circuit a few times and it's worked well. I've seen a lot of, here's an example because I just copied this from online. You know, stuff like this. I haven't reverse engineered how this circuit works yet. Also, I forgot to draw that there. That goes to the feedback. That's what that point is there. I forgot to point that out. I didn't draw that line there. These are the two drives that go to the amplifier. So if I'm using this circuit to drive this, these 2 points here that get attached here will also go to that point and that point. All right, that's how it would drive it. And then these 2 points would go to the that second, I'll just show you, off of here, off of this power source, right? Actually, I've just realized something. I'm not thinking. Oh no, that's right, yes. No, I wanted to do that for the driver. Never mind. I just had a silly moment. So this would be powered again, going back to the power supply. With its own, like its own separate wires. It wouldn't be powered off of another. It's not going to be daisy chained, is what I'm trying to say. Bloody hell, I couldn't get that out, eh? Now, something else to consider here. None of the transistors that this is designed with I'm going to be using. Number one, BC550, 560 is just, not that they're bad transistors or anything, but the voltage rating on them, actually I can't even think, what is it, like 55, 65, 45, I can't think, it's in that ballpark. I'm just turning my lab computer back on. I'll tell you in a moment. But I'm going to have to put different transistors in here. Now, I'll give you guys a quick look because I'm always saying how many transistors I've got, and sometimes I'm having a look for output devices or drivers, and you guys get to see a quick glance, but I'll go over and we'll have a look at my small signal transistors. So not driver transistors, nothing like that. So you'll find like BD stuff and J113s, J103s, K246, JFETs. Just all random stuff scattered around. And then it continues down here. Basically, this isn't small signal transistors, but I'm just giving you a look at what I have. Right, and then I have all of this. So let me put the light on. Oh, my phone's flat. Damn. I'll just go slow so that you can read it. Right, and then there could be a couple of random devices in some of these boxes. No, there's going to be a couple of little things over here. D649, 669, some op amps, instrumentation amplifier. Alright, and then there's another whole load of transistors over here. So you get what I mean when I say no problems when it comes to all that sort of stuff. Give you a quick look at everything. Why not? So that's what I'm up to now. I finally got all my components in drawers. I just need to organize the drawers. As you can see, I've got electrolytics in the same thing that's got diodes, in the same thing with photocells and crystals and CA3160 and PC123s and You know, it's small bulbs, it's all mixed up, you know. I've got to sort out all the drawers. This is because over the years of buying drawers and adding stuff, you know, it's just, yeah, it's the way it is. But now it's all organized. I will go through it all. Oh, you just looked at that. I'll go through it all and I'll organize it. This is what I mean when I say it's insane the amount of stuff that I have, and yet somehow I'm always still needing to get stuff for that project, you know? You can never have enough components, I'm telling you. No matter what. Getting dead arms holding the phone. That's alright, I don't mind. My apologies for the phone being flat, otherwise I would have the light on and you get a much better view. Shit, there's still more transistors down there. You see what I mean? There's stuff scattered everywhere in here. Even I didn't even know they were there. Goodness. And look, you see what I mean about everything's just, you know, like over here I've got capacitors and resistors in the same box. Yeah, we've got panel meters, pots, 25 turn pots, 10 turn pots, wire wound resistors. You know, look, half of my green cap, mylar, poly caps are over here. Half of them are over there. Half my monos are here. The other half of them are here. I really need to go through this place. Here's the, what do you call it? Oh, exactly what you see. Weemer caps. Are they Weemer? I'm going blank. Yeah, Weemer. The high quality shit. And tell you now, they're not all what they cracked up to be. They might have good tolerance, but some of the other specs aren't as good as what you might think. Depends on the cap. That's why you have to pay attention with these caps as to what type of cap they are. They're all applicable to totally different circuits. So don't just go thinking because they're expensive or whatever that they're really good caps for everything. It doesn't work like that. This is what happens when you collect for years and years and years and years. Geez, more transistors, oh my god. That's what I mean, like there's just stuff everywhere in here. I really need to go through everything. UA 741s. Wow. Wow, I didn't even know I still had one of these. Cool. Right. We're getting there. I've got a few things over here. Breakout boards that I make. not much in there at the moment. Heat-proof wire and insulation. Not much in there. Sheets for insulating stuff. LCDs that get salvaged out of things. Some random resistors. Random mixed ICs. Oh my god, I didn't even realise I had half of this crap. Jesus. And I've got more bloody resistors that I had. Like, seriously, I've had some of these since I was probably in primary school. And it still lives on. And then over here we've got the logic ICs. Yes, don't worry, my HCs and my LSs are separate. I think we've already had a look over here. So that is my component collection, right? I also have some spare stock under here. Like I go to warehouse clearances when Jake, or I don't know if they're going to have any more now, but because they redid their warehouse and it's pick and place, like it's all machine, there's less people there. But they used to do warehouse clearances, you know, like, oh, you got mad deals. Like this roll of copper, right? I know it looks empty now, but let me show you something. I'm not going to get a light down here. You see all that copper in there? Yeah. I wrapped that transformer and it's huge. I mean, yeah. Imagine 4 microwave transformers squished together. It's a welding transformer out of 160 or 180 amp, maybe even more, stick welder, and I rewound it. Well, the copper it took to do that and a few other things, and what's left on there, you know how much that cost me? $20. I got whole boxes of capacitors. Rolls of capacitors. $2.50. Resistors, $1 a box. More resistors, you know. And then over here I've got just more stuff that I use to replenish my stock as it goes out. Sometimes if I get stuff in bulk, you know, I only put a little bit in the drawer and the rest sits over here. You know, there's packets of capacitors that I've gotten from those warehouse clearances again. You know, resistor packs to replenish my resistors. They're bought from JCar. These resistors are bought from AliExpress. You know, same with those. These came from JCar warehouse clearance. A whole load of bipolar 4.7 mic 100 volt for crossovers. Not that I would use electros in crossovers, but the cheap shitty crossovers. And then more resistor stock. I'll just bring this out in the light. Again, so when my drawers get empty, I usually just come over here. So it's very rare that I have to buy resistors because I've got, you know, I've got all this here, and then I've sort of bought the odd values that I use the most, and then some kits. So I usually just come over here and fill up my drawers as they're getting empty. But other stuff that aren't resistors and certain capacitors I've already got that I do have to order when I run out. But yeah, and then I've got all this over here. I've got just a whole load of just random transformers, you know, just all different types of transformers. Just there's another huge one that I built in the back. I know you can barely see it. That huge toroidal that's got welding transformer wire wrapped around it. That's a huge choke that I built out of. Oh, it was a choke. I've just made a different choke out of a choke. More transformers, ballasts, transformers, just transformers, switches, switching supplies, and then I've got some spare TV repair parts, you know, all the LVDS driver boards and stuff like that. And then over here, more resistors. And that's it. So yeah, so I'm sure everyone saw the transistors, the small signal transistors everywhere. I've got basically every small signal transistor that exists almost, you know, so it's not going to be a problem sorting this out. I'm thinking MPSA 42s, MPSA 92s. Well, I've got to break down the voltage and work out how much is across everything. I might not actually need transistors at high voltage, but, you know, I might better use like... Actually, I've got my computer on now. I can get some data sheets up. I'll tell you now. Let me just see what the BC550s are, because I can't remember what the collector to emitter breakdown voltage is on them. Okay, so, oh, really? 50 volts. Okay, was pretty close. Well, they're not going to work. So, what are BC55551s? Look, I'm not going to do this on video and waste your time, but the point is, I'm going to have to change the resistor values because it's going to be on a higher rail voltage, and I'm going to have to use different transistors. Also, these transistors I want thermally coupled together, and I'm going to match them down to them as much as I can, you know, like perfection. So yeah, the other thing I've got, this is what I was going to say before. I've got to reverse engineer this input because from what I can see, you've got this 10K resistor here, 4.7K, so you've got about 15K after, just ignore that, that's just blocking DC. You've got about 15K here before the signal gets into this side. And you've got 470K on the ground side. I find that a little bit confusing. I don't know what they're trying to do there. I think they're trying to filter some noise out, high frequency stuff or something like that. I'm going to look into that because I've got a really good feeling that that's just going to go. I may end up with something like, you know, 10K or 1K or 4.7K. I've got to do all the math on this, you know, but in each side, or maybe nothing. Hold on. Because I wouldn't mind using that. Oh wait, we've got 15K. Yeah, that will work good. That would just be 15K across each side with audio writing on it. Yeah, so that, unless I'm missing something, that should work fine. So I won't rub that off the paper for now because, you know, I might end up having to use it. I'll leave it here. What I am going to do Sorry if everything's a little bit messy. Like I said, the reason everything's like this is because I'm in the design phase. I'm changing stuff as I'm going, you know. When I'm happy with it, like I said, I'll make a schematic for everybody. Anyway, so this is what I'm thinking. And then, well, obviously, these are not going to be BC 550s and 560s. That's just not going to happen. Yeah, no, that's not going to happen. Not in a long shot. Oh. For now, let's just say, I can't think what's what. I think A92s are PNPs, but I could be wrong. A92, A42, 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 what is it? 92. I might actually end up using them, who knows? Maybe not. I might end up using like the A92 and A42 for these two, and something more appropriate for long tail pairs and audio, you know, smaller capacitance, high transition frequency, stuff like that, you know. Again, to be decided still. Now, resistors, look, our voltage is basically going to be about double what's here, but pretty much is going to be double. It's about 50 to 55 volts, the rail. 5 volts isn't going to hurt anything for the first build if it's next to 5 volts and I've got to slightly change resistor values. The thing's not going to go up in smoke. So that's good because we can just halve all our resistor values basically, because this is all symmetrical. This resistor is sourcing the current for here. This resistor is sourcing current here. This resistor and this resistor and these two LEDs and that is setting these two up. So everything is symmetrical. So I should be able to just double everything if I've got this right. I will sit down in my own time and actually study this and have a little think about it. Just in case, you know, I'm missing something, but that's basically what the plan is. And I'm going to build this up on breadboard at some point tomorrow, because, you know, I've got a scope in here, a decent scope with F15 and stuff like that on it. I've got a function generator. I've even got this little load bank that I built specifically for this, for building amplifiers. What this is, you know, like, that's one of my projects coming up in the future, is a big load bank for actually loading the output down. And I mean like a good 250, 500 watt per channel load bank. You know, cooled, that can continuously dissipate power. Or at least for a while without the resistance going up, skewing the measurement, you know, due to the heat. What this is what it looks like. You can put your signal in here. You can take the ground out if you want. You don't have to have it grounded. This ground is attached to the box, and ground planes that go in between all the traces on the board. Actually, I'll take it apart and I'll show you guys in there. So what this is, you can put 2 channels in, and you can look on the scope, and you can switch in and out different loads. And I've written on the bottom of it so you can't blow it up. The entire circuit from this end to this end, maximum 25 picofarads, 70 volts. I'm not sure where that rating came from. There's got to be a reason for it. Maybe we'll know when we go in there. I built this thing years ago. For the 470 ohm resistors are 10 watt, the 1K are 5 watt, pots and high value resistors are 0.5 watt. So, you know, this can still do a bit of power for testing drivers and like intermediate preamp stages and stuff like that. And the beauty of it is you can load your stage down, you know, adjust the load on it. You can switch these pots in and out and bring them between 10K and 1 meg. And you can load down your circuit you're designing whilst you're looking at it on the scope, which is a lot better than just putting the scope on your circuit. So I've got all that stuff already. So I'm going to start building preamps tomorrow. I'll come back from Jayco, obviously, and we'll do the transistor matching first, because that's all I've got left in terms of parts for this build to sort out is those transistors. And obviously I'm going to have to match these ones. But yeah, that's what's going on there. Okay, something else. This is only a small little update, but I still want to point it out. These are the speaker output jacks that I'm going to be using for the amp. These are the RCA inputs. These are all salvaged off the old amps. I've just been cleaning everything up. Yeah, you can see the solder. I've just been cleaning everything up, like I said today. This is shielded single core. The reason for this, and don't get me wrong, I have right here. As Ave would say, focus you fuck. I don't know if anyone watches Ave's channel. Let me just get some more light. Twin and shield, right? The reason, I believe, when I'm building an amplifier, the signal going from my RCA to my circuit board, left channel, single core and shield, right channel, single core and shield, and these are not even next to each other. I don't want crosstalk because I've got a section of cable with 2 wires inside. I've never been able to get my head around that, you know. When you're building an amplifier, you're trying to get good common mode rejection, as small crosstalk as you can get between channels. I just don't understand why people do some of the things they do, but that's what this is for. So everything, you know, the way the circuit will be designed will be literally on 2 separate halves of the board, or maybe two boards per channel, you know, like for each channel. So, you know, there's not going to be traces next to each other, not even the circuit next to the other channel. Even the input signals will be on separate cables, you know. Because, you know, that's something that really adds to your sound stage, is your stereo separation. And the more you screw that up with crosstalk and stuff like that, you're ruining your sound stage. So, yeah. Other good news I've got, I started pulling apart these old amps. And guess what? This is wonderful, because, you know, I was saying I've got to soak the wood. Well, guess what? I don't know if you can see that. Yeah, that's silicon. If it's not silicon, it might be araldite. It's not liquid nails, which is what I thought it was. So I'm going to be able to just go get my crowbar and just pop this off. And as you can see, they're almost cleaned up. Like I said, I was going to get that done today because I haven't got them done the last 2 days. I've been doing other stuff though. So yeah, that's what we're up to. Like I said, only a small little update, but I'm trying to document everything as I go, and also, how do I say this? I'm trying to not just document it, but explain the process as I go. So you guys can understand my thinking, and so other people can understand how this stuff works. All right. That's all. Ignore this for now. My transformer has a separate winding on it, and I was thinking about doing something different, but I'm going to build my own preamp. I was going to basically be a lazy prick and use an op amp, like a FET input op amp, so I don't get DC offset, and run that into a VAS and drive it with that. And this was going to power the op amp. And then I was going to put a regulator on each rail, like lower voltage, to get, you know, roughly the same voltage, but better regulation and noise rejection. And then I was like, no, you know what? I'm just going to stick with that and this. I'm going to make up both of these, by the way. and this I'll experiment with it too. I'm going to do this first part, but I just want to see how much performance you can get out of a single transistor. But instead of it having this 3.3K resistor as its collector resistor, dropper, where the signal signal's made across that resistor, or across the transistor. You know what I'm trying to say. I want to replace that with a current source, and maybe do something down here where the emitter resistor is too, the degen resistor. And I want to see, with that driving the amp and negative feedback, how much performance can you actually get out of a single transistor? I just think that would just be an interesting experiment to do. Leave it in the comments if you think that's interesting. Because I've seen so many people on YouTube just build these little, you know what I'm talking about. You know what I'm talking about. I see this too often. Simpleton stuff, you know? No, what if we actually design a proper compensated amp with a full current source and everything, you know, and actually dial it in and give feedback and everything? How much performance can we get out of it? I'm just curious. Like I said, this is what I'm building tomorrow. I'm going to start adjusting values, choosing transistors, working out the input section for it. You know what I mean by input section, not that bit. And yeah. Alright, that's all I've got for now. I just wanted to make a little update there. I'm going to pop these heatsinks off and go to bed now because it's 3:30. I've stayed up late the last few nights and I thought I was going to be tired because I've actually done a bit of stuff today, but no. Anyway, I might pop these heatsinks off in the morning. It is actually getting quite late. Yeah, I'm going to go to bed now. Alright, well, I'll see you all tomorrow. I'm going to go to J-Car, sort out these chip transistors, come back, and we'll get a move on. Thanks for watching.